Hey everybody, this is the notes for section 5.5. This is addition and subtraction of polynomials. This will be largely pretty familiar. So remember this definition. When we're talking about polynomials in one variable x, it's defined as a single term or a sum of terms. So it's a bunch of, you'll see it, variable terms together where the form ax to the n is the real number and the exponent is a non-negative integer. Each term has a part A called the coefficient, n is the degree. So if I have 3x to the fourth, 3 is the coefficient, n is the degree, the 4. So this is the coefficient is 3, x, the n, it's a fourth degree, okay? So if we look at this, these examples, I have negative 12z to the nth power. The coefficient is negative 12 and 7th degree. X cubed, I could rewrite as 1x cubed. So the coefficient is 1 and the degree is 3. 10w, the coefficient is 10. And if there's no exponent on something, we know there's no 1 there. And then 7, I could rewrite as 7x to the 0 power. There's no x's if I was really being picky about it. We don't often do that, but that's the truth of it. So it's a 0 degree. Often, sorry, before I move, this is often when it's just a 7 by itself, it's called a constant term. Typically, we put those at the end of the list. So a polynomial has one term, it's called a monomial, mono 1. 2 term is a binomial, and a 3 term is a trinomial. Anything more than that is just simply a polynomial. The term of the polynomial with the highest degree is the leading term, and we write polynomials from greatest degree to smallest. So we write them, if you look at this bottom one, in descending order with the term to the highest degree written first. That's what the standard form is. So I might have something like, let's see, 3x to the third plus 2x squared plus x plus 4. That's in standard form. The coefficient, this 3x to the cubed, 3x cubed is the leading term because it's at the first and it's got the highest degree. The degree of the polynomial is the greatest degree of all of its terms. So this is a third degree polynomial because the greatest n, the greatest exponent, is a 3. So for example here, there's just a list of some of the different kinds of things we're going to run into it. An example of a monomial is negative 3x to the fourth. Leading coefficient is negative 3. The degree is 4. Another monomial is 17. This, again, is something that we'd think of as a constant because it doesn't have a variable term. Binomials, things like 4y cubed minus 6y to the fifth. Typically, it would be written in the second way as standard form with the negative 6y to the fifth first. In the second one, you can see half minus 1/4 c. Typically, you would write any variable before you would write a constant. And then you can see trinomials on the bottom. You can see the degrees. You know, this is pretty self-explanatory, this chart. So given a polynomial, the one here, list the terms, state the coefficient and the degree of each term, write it in descending order, state the degree, and evaluate it for a equals negative 2. So there's a bunch of things to do here. The first is list the terms. So this 3a is a term, negative 2a to the fourth is a term, 6 is a term, and negative a cubed is a term. 3a is a first degree. The coefficient is 3. Negative 2a to the fourth has a coefficient of negative 2, and it's a fourth degree. 6 is a 0 degree because there's no x term on it, right, or a, and the coefficient is 6. And then negative a to the third, the coefficient is negative 1, and it's a third degree. The polynomial in descending order, we got to look at the highest exponent, would be negative a to the fourth minus a cubed, oops, that's a 3, plus 3a minus, no, plus 6, okay? So I'm going to pay attention to the order of the exponents. And this one technically has a 1, and 6 has 0. And then the highest degree here is a 4. So the degree of the polynomial is a fourth degree, and the leading coefficient is negative 2. And then if I want to evaluate it for -2, that means I'm going to put -2 in where I see a. So I'm going to have -2 times -2 to the 4th minus -2 to the 3rd plus 3 to the -2 to the 1st power plus 6. 2 to the 4th is 16. -2 to the 4th, still 16, times -2 is -32. -2 to the 3rd is -8. -8 is plus 8. Let's see, -3 times -2 is -6, plus 6. So when all is said and done here, I'm going to end up with -24. I should like make my notes in front of me to make sure I have the right answer, because you know how silly things happen to all of us. Yep, I'm good. Okay, so you do the same thing on the next slide. Okay, you write out the polynomial in descending order, state the degree and the coefficient, and then evaluate it for -1. I will tell you that this is a 4th degree polynomial. This leading coefficient should be 8. And when we evaluate it for -1, the answer should just be 1. And if you get stuck, come on into the discussion. You know how to get there. Okay, so some additional kinds of things. When we add polynomials, the only time we get to add them is if the variable terms on the end are exactly the same. So I can add x squared y plus x squared y, but I cannot. A different thing would be if I had x cubed y. Those don't match. They're not exactly the same. So only these two first terms would match together. So with the variable terms, it's almost like a fruit. Like x squared y, and x squared y are like oranges. I can combine oranges and have more oranges. But I can't combine oranges and bananas and get something new out of that. That's not okay. So in this one, I have 8. I have 3 of them, and then I have 5 more. I have 8x squared y. Look at the next one, the same n, same coefficients, or sorry, same variable term. So I have 13 of them, and then I have 2 of them. That's just 15. A squared b cubed. They're just 15 of that thing. Notice I'm not changing the variable terms at all, just how many of them I have. Okay, so let's add some more. So here, remember that this would be like distributing a +1. And when I do that, the parentheses just go away. So I have -3c cubed. Oh gosh, sorry, I'm going to write that so you can read it a little more effectively. -3c cubed plus 5c squared minus 7c plus 11c cubed plus 6c squared plus 3. So what I'm going to do here is I'm going to look for things that are the same. This is -3c cubed, and I have 11 of those c cubed. So -3 and 11 is 8c cubed. Now I'm going to look at the next term. I have 5c squared, and I also have 6c squared, so I have 11 of those. And then I have a -7c. That guy doesn't have a partner, so he's just going to get tacked on the end. And I have just a 3, so +3. If it doesn't have anything to combine with, it just gets tacked on. That's all it is. You guys try the next one. Let's see how it goes. Okay. Somehow I got my slides out of order. You saw me do that, right? Okay. So, So in this case, I have, as an answer, I have 12q squared plus 4q. Oh my goodness, that's a squared, pardon me. 4q minus 5. Make sure that is the same answer you get, and then let's see if you have any questions, bring it into the discussion. All right, let's try the next one. So in the next one, I'm going to add these same way. I'm just going to pay attention to signs. So I just switched those slides around. That's what happened. I got myself out of order. Okay, so you try these ones. For the first one, let's see. I'm going to match up the w squareds. I'm going to match up the x's. Okay, so I'm going to get 7w squared minus 4x squared, that guy didn't have any partners, plus 4x. Okay. Okay, so now look at the next one. You try this one. Okay, when you get done, what you should have at the end is 2x squared minus 4xy, because that guy doesn't have any partners, minus 4y squared. All right, okay. So moving along. Find, when we talk about the opposites of polynomials, it's just the opposite. So when we have an opposite, it means the two things, when I add them together, equal 0. So if I have 5x, what can I add to it to make 0? Well, I can add negative 5x. That's the opposite of 5x. For the second one, the opposite of 3a is negative 3a. The opposite of minus 4b is plus 4b. And the opposite of minus c is plus c. That's the opposite. Same thing in the next one. The opposite of 5.5 is negative 5.5 y to the fourth. The opposite of negative 2.4 y to the third is plus 2.4 y to the third. Ooh. And then the opposite of 1.1y is just minus 1.1y. Okay. So we've added, now we're going to subtract. The thing about subtracting is we really have to pay attention to the signs. A minus b, remember, is the same idea as a plus a negative b. They're directly correlated. So when I subtract the polynomial, the thing you really have to pay attention to is right there. Because really what I'm doing is I'm distributing that negative 1 to everyone. So I have to actually do that. So here, instead of just breaking up the parentheses and living with what I had, I have negative 4p to the fourth plus 5p squared minus 3 minus 11p squared minus 4p plus 6. Now that I did that, oh, not 16, just 6. Let me write that better. Now that I did that, I can combine the terms. So how many p to the fourths do I have? Well, just the one. So I have negative 4p to the fourth. How many, do I have any p cubes? Nope, I don't. So I have plus 5p squared minus 11p squared. That's going to be minus 6p squared. I have just, let's see, minus 4p. And then I have minus 3 plus 6, so plus 3. All right, that's it. That's done. Okay, let's see. That was a minus. Oh, wait, you know what I did wrong? Did you see it? Okay, when I looked at the first term, it was a minus 4. No, it was right. Minus 4p to the fourth. I did it right. I know what I did. Okay, so next, take a look at the one on the bottom. It works the same. Distribute the negative first, then break everything up. X squared plus 3x minus 2 minus 4x squared, and it's got to go to each thing, not just the first term, minus 6x plus 1. So now we'll combine. So let's see, I have x squared and minus 4x squared. That gets me negative 3x squared. 3x minus 6x would be minus 3. Come on, x. And then negative 2 plus 1 gets me minus 1. Oh, it should have been a minus 1. I didn't distribute, even as I was talking to you about distributing all the way through. So that should be a minus 3. That's why we check our work, okay? So that we make sure we're doing it right. All right, you try these two. Check your notes. try the process, make sure you distribute properly. For number 1, when you get done, it should be 9a squared minus 8ab. Nope, I think I did something wrong there. Let's see. Distribute that minus, that's going to become plus, a plus, and a minus. So I have 9a squared minus, so that's plus 4ab, and then plus 5b squared. All right, you try the last one, pause, and work it through, right? So I am going to make that a plus, and that a plus. So I'm going to get minus 1y squared plus 4xy, because I have 1 of them and 3 of them, plus 10x squared. All right, let's try something a little more complicated. Subtract 1/3 t to the 4th plus half t squared from t squared minus 4 and simplify the result. In this case, it's just telling you to think about how you write this. So I'm subtracting it from, so the t squared minus 4 goes first, minus, in parentheses, this whole thing, 1/3 t to the 4th, oops, plus half t squared. I'm not going to freak out over the fractions because it doesn't really matter, so watch. I'm going to distribute that negative, so this becomes a minus, that becomes a minus. I don't have any other t to the 4th, so I just have minus 1/3 t to the 4th. I have a half, I have a t squared, so 1 of them minus a half of them, so I just have a half left, so I give you half of something. So I have half t squared, and then minus 4. That's it. Okay, you try the next one. Subtract 3/4 x squared plus 2/5 from x squared plus 3x. So x squared plus 3x goes first, minus the quantity 3/4 x squared plus 2/5. I'm going to distribute the negative, which means I'm going to switch everybody's sign. Those become minuses. 1x squared minus 3/4 is just 1/4 left, right? 1/4 x squared plus 3x minus 2/5. That wasn't terrible. You didn't die. All right, one more kind of thing. So if the perimeter of a triangle in figure 5.1 can be represented by the polynomial 2x squared plus 5x plus 6, find a polynomial that represents the length of the missing side. I don't know this side. So before we stop and think about it for a second, let's remember how we find perimeter. Perimeter is side plus side plus side, right? When we find the perimeter of something, we add up all the side lengths. So what it's saying is I have 2 sides out of 3. But I don't know this last one, but I know the total. So what I'm going to do is I'm going to do 2x squared plus 5x plus 6 minus the other 2 sides, 2x minus 3 and x squared plus 1. Those two, if I add them together and subtract them from the total, I get the last one, right? So I'm going to distribute, and I'll rewrite. So I'm going to run out of space. 2x squared plus 5x plus 6 minus 2x plus 3 minus x squared minus 1. So now I'm just going to combine the things that go together. So I have 2x squared and minus x squared. That just means I get x squared. I have 5x and minus 2x. So that's plus 3x. And then I have 6, 3, and minus 1. So that's going to be plus 8. So the missing side length is x squared plus 3x plus 8. Okay? All right, there's one more problem just like this. Oh, where'd it go? Here's the last one. Same exact problem. Somehow I moved the words off the screen. Oh, they're there. So if the perimeter of the triangle is represented by the polynomial 6x minus 9, find the polynomial that represents the missing side. There's the missing side. So 6x minus 9 minus all of x plus 4 plus 3x plus 2, or 3x minus 2, pardon me. So now distribute the minus. So 6x minus 9 minus x minus 4 minus 3x plus 2. Now combine stuff. Let's see, 6x minus x minus 3x. 6 minus 1 minus 3 leaves me 2x. I have minus 9 minus 4 plus 2. So that's b minus 11. That's all it is. It's done. 2x minus 11. All right. This is the end of the notes for this section. If you have questions, please come on into the discussion, or better yet, send an email and ask for help. Good heavens. If you're stuck, I want to hear from you. Okay?